Hello, and welcome back. So over the past couple of videos, we've been working on doing nodal analysis on this circuit, and we were able to get the circuit reduced down to 3 equations and 3 unknowns. And so now really kind of what's left to do is just really an algebra problem. It's an algebra problem about trying to figure out how to solve 3 equations and 3 unknowns. And really, I guess the first place to start with this, and what I'm going to do over the next few videos, is I'm going to give you a bunch of different alternative ways that you should solve this. Really what I should say is every way we're going to solve this is equally valid. At this point, this is an algebra problem. However you choose to solve 3 equations and 3 unknowns, so long as it gets you the right answer, that is equally valid. You can solve it in any of those ways. In order to do that, though, what I want to do is I want to get each of these equations that I've got. So I've got 3 equations and 3 unknowns. I want to get each of these equations that I've got. So I've got this one right here, this one right here, and this one right here. I want to get each of those equations into this particular form. I want to get those equations into the form some constant A. So some constant A, or actually I'm going to write it as some constant A equals my voltage V0, times some constant little a, lowercase a, plus my voltage V3, my unknown V3, times some constant little b, plus my last constant that I don't know, my constant my variable that I don't know, my variable I1, times some constant lowercase c. I want to get each of these 3 equations, zoom out, I want to get each of these 3 equations, this equation, and this equation, into this form of some constant capital A that I've got here. And notice that capital A will be different for each of these equations, is equal to V0 times some other constant plus V3 times some other constant plus V1 times a fourth constant. So this might be a good point to try to pause the video and do this on your own, to try to refresh this and be able to do it. And right now what I'm going to do is I'm just going to start doing that. I'm going to start rearranging these expressions. So to start out doing that, let me go ahead and I'm going to take this equation and I'm going to kind of break this up a little bit. I1 is still going to remain I1. Or else actually what I'm going to do, I1 is still going to remain I1. That's going to be equal to 3.3 divided by 6 minus V0 divided by 6. Notice what I did. I just broke up that fraction. If I have A minus B divided by C, I can rewrite that as A over C minus B over C, right? I can just break this up. So I just broke up that first fraction, and now let me go ahead and break up the second fraction. Plus 3.3 divided by 4 minus V3 divided by 4. So now I've gotten this all broken up. And now let me just kind of collect like terms. So now in this expression, I want all of my constants over on, actually, you know what, I'm going to reverse this. Instead of having my constants on the left-hand side, I'm going to have my constant on the right-hand side. So I'm going to have all of this equal to a constant A. So now let me bring over my V0 next to my I1. So I'm going to add V0 over 6 to both sides. I'm also going to add V3 over 4 to both sides. I'm going to be left with I1 plus, and I'm going to write V0, this V0 term like this. I'm going to write it plus V0 times 1 over 6. So hopefully that makes sense. I added V0 over 6 to both sides. And now I'm just rewriting that as V0 times 1 over 6. Now I'm going to do the same thing with v3 over 4. I'm going to add v3 over 4 to both sides. I'm going to rewrite that as v3 times 1 over 4. And then my left-hand side of the equation, where I need my constant a, that's just going to be equal to 3.3 divided by 6 plus 3.3 divided by 4. And, like, you know, if my end goal is to put this into a calculator, I'm done, right? I've got I1 times a constant. My constant here is just 1. V0 times another constant. That constant's just a sixth. V3 times another constant. That constant's a fourth. And then everything over on this side of the equation is a constant. 3.3 over 6 plus 3.3 divided by 4. So I'm done. I've rearranged this equation exactly the way I want it to be. Let's go ahead and do the same thing for this second equation. Go ahead, change colors. So, and let me also just label this. This was equation 1. So now for equation 2, let's go ahead, and the first step is to kind of break up all of these fractions. So I'm going to be left with 3.3 over 6 minus v0 over 6 plus v3 over 12 minus v0 over 12. That is going to be equal to v0 divided by 15 minus 0 divided by 15, but that's just 0, right? So I can actually ignore that term. Like, I could put minus 0 over 15, but that whole thing is just 0, so I'm just going to leave it out. And now let me go ahead and rearrange this. So now I am going to rearrange this to get everything on this, all the variables on the right-hand side, all the constants on the left-hand side. So let me group the like terms together because I've got 3 different v0 terms, right? So I'm going to have minus v0 over 6. Actually, let me change colors back again. I want to keep this color. Minus v0 over 6 minus v0 over 12. And now I'm going to subtract v0 over 15 from both sides. Minus v0 over 15. Oh, why did I write 16? That should be 12. So minus v0 over 6, that's that term. That is that term. Minus v0 over 12, that's that term. Minus v0 over 15, that's that term. And then I have a v3 term, so I'm going to have plus v3 divided by 12. And that, so that's that term, and that is all going to be equal to this constant. So I'm going to subtract 3.3 divided by 6 from both sides. And I'm going to be left with minus 3.3 divided by 6. Notice I'm not really simplifying too much of these expressions numerically. Because if my end goal is to put it in the calculator, I want the calculator to kind of do all that work for me. You know, I don't really want to do more work than I absolutely have to. So now, the last step of this is just to factor this v0 out from all of these constants, factor this v3 out from the 1 over 12, and really we're done. We've got it into our form. So I'm going to write this as v0 times minus 1 over 6 minus 1 over 12 minus 1 over 15 plus v3 times 1 over 12, and all of that is going to be equal to minus 3.3 divided by 6. And that is my second equation. So now I'm going to go and pretty much do this for the last time. I'm going to do this with my third equation. So now for the third equation, I'm going to come down here, third equation. And the first step is to split up all the fractions. So I get 3.3 over 4 minus v3 divided by 4 plus 1 is equal to V3 divided by 12 minus V0 divided by 12. And now I'm just going to combine all the different V3 terms and V0 terms and move the constants over to the left-hand side. Or no, that's the that's the right-hand side. This is the left-hand side. So I'm going to move all the constants over to the right, move all the V3 and V0s over to the left. So I'll have minus V3 divided by 4, subtract V3 over 4 from both sides, so minus V3 over 12. And then I'm going to add V0 over 12 to both sides, so plus V0 divided by 12. And then I'm going to subtract 3.3 over 4 from both sides and subtract 1 from both sides. So minus 3.3 over 4 minus 1. And now the very last step is just to factor out this V3 and that V0. So I'll be left with V3 times minus 1 over 4 minus 1 over 12 plus V0 times 1 over 12 is equal to minus 3.3 divided by 4 minus 1. So now what I've got is I have got 3, and this is my third equation, is I have got 3 equations, 3 unknowns, and I have got those equations into the exact form that I want them to be in for them to be kind of of most use to me. So anyway, I'm actually going to end this video here. In the next video, I'm actually going to start down. This is, it's again, we're at the point where any way you choose to solve 3 equations and 3 unknowns is equally valid so long as you get the right answer. In the next video, I'm going to go over a little bit of linear algebra. It's like the minimum amount of linear algebra that we need to kind of survive in a circuits class, I guess. And then in subsequent videos, I guess we'll apply it to solve this problem. So anyway, thanks for watching, and I will see you in a future video. See you soon.